Alright, let's see what we got. 354.6, 358, and 357.5. Across each hot, we've got 619. Hey, what's up guys? Today's video, we're going to be energizing a large commercial building for the first time. It's not as simple as simply closing in the cutouts. There's quite a few checks that we have to do along the way, and we're going to take you all through that process. So just a quick look at the job site. This is the pole here that's going to be energizing the pad mount transformer. There were some crews on site that just pulled this underground and framed this pole up yesterday. You can see the cutouts are not currently tapped on, so I will have to get my truck in there, install those risers, and close that cutout in, which will energize the pad mount transformer. Our first obstacle is I can't get my truck in there, so I imagine we'll get a hold of someone, go around the building, go in through the compound, as opposed to driving over that tech cable that's laying on the ground there. Another thing we'll have to take a look at, there is a transformer bank in behind that trailer there. Some Quadrex run, some 3-phase low voltage cable going over to this C-can feeding temporary power. So we're not allowed to have 2 feeds going into a building. I'm not sure if they have that tech cable running into the main meter room, what the story is there. So we're definitely going to be looking at that. We may end up disconnecting that before energizing it. There could be, of course, there's another cable running to a construction trailer over here behind me. So we'll look a little bit further into that. A couple more things we want to check is permits for one. The permits are all in place. I got this phone call from the boss that this customer is looking to have this building energized today. So before we can energize these buildings, we have to have permission from the provincial electrical inspector. Any of these large commercial buildings that get built, the inspector has to release that everything's okay inside before we can energize the main feed. So that's already been done. The permit's in place. Provincial inspector has been on site, checked things out on his end. I will go in the meter room and double check things as well, of course, even though it's not really our baby. If I see a wire not tied in or something that's obvious, then obviously I have the jurisdiction to not energize it. So we're gonna go inside and take a look at that. Another thing that's important is I don't want to energize that for the first time if there's guys working in the meter room. I haven't been in there yet, but it's probably a small enclosed area where all the electrical equipment is. And even if everything is tied in correctly, it's not a perfect world. There could be some equipment failure, something could explode. There's probably a large disconnect switch. It's not a situation where the power flows through the meter and is metered. It's a situation where there's a meter that's tied into some PTs and CTs that tap off the main lines to get those readings. So if there's a manufacturer's defect in any of the equipment, there could be a hazard. It's very unlikely, however, definitely a possibility, not worth the risk of having somebody in there when we energize all this equipment for the first time. That goes for the pad mount transformer, the cables themselves, brand new terminations, which would have all been measured and stuff. So it should all be good to go. However, we're going to follow all of our procedures as we always do throughout this process. So I think what I'll do first, I'm going to go inside and take a look at the meter room, and we'll show you guys what we got inside there. Quite a busy meter room, actually. There's quite a few guys still working in the area, so we're definitely going to get this cleared out when we energize that. You can see not all the electrical work is finished. However, the main breaker is tied in right now, and it's currently locked and tagged out. Just above the main breaker, we have a cabinet that has the PTs and CTs enclosed. That's the current and potential transformers. It's a bar type. So those are conductors, those huge metal plates, and the power flows through those CTs and transforms that at a 120-to-1 ratio. Those are 600 amp CTs. I'm just checking to make sure that the jumpers are removed there. So if you got 600 amps flowing through that, we're going to read it at 5. And these are 3-to-1 ratio transformers that transfers the voltage down from 347-ish to about 120 volts. Just so that when that information goes through the meter, it's easily readable through small wiring. We do seal this cabinet, of course, so that nobody tampers with any of that equipment, which could affect the building and the readings. And that's checked monthly. This is read in person. Someone will come in here and check that meter, mark down the readings, and check to make sure all the seals are in place, as well as the readings on the meter are multiplied by the billing multipliers. So everything looks good inside. We're just going to go back and clear out that room. There's quite a few guys working in that room right when I close in the switches. I'll go up in the boom and tap them on. I'll close those in from the ground. Here's a little bit better look at the temporary power. So there is a transformer bank on that pole that's feeding 3-phase temporary power that they used throughout the construction of this building. Once it's energized, should back up here. We are going to leave that temporary power energized for today. You can see where there was a lockout on the main switch. The customer is going to have a power interruption tomorrow where they're going to disconnect temporary power. They'll open the main breaker at their temporary, at the C-can there. They'll disconnect that and then switch over to the main power. Once that's done, they'll advise us. We can open the transformer bank and dismantle. We'll have all those 3 transformers completely removed from the site probably by next week. So we're going to set up the truck. Still got one more gate to make it through there. I'll slap on the GoPro and we'll go get those leads tapped on. So we're still waiting for someone to unlock this gate for us so I can get over to that pole. Just while we're waiting here, oh, here comes somebody now. But back up the truck a little bit. Yesterday, I was driving down a secondary highway, super busy road, came across some triplex hanging low, almost hit it with my truck, stopped, tried to kind of control traffic. If a transport had to come by, it would have caught that triplex and definitely snapped a 3-phase pole. So we did have the police come out, and I called our own guys. They were a half hour away. Flaggers were even longer. So the police came out, stopped traffic, and I was able to temporarily secure that triplex. However, while we were there, the customer at the driveway, right where I stopped, he came outside and we responded to a broken pole right in front of his house last year. He had a video on his phone of the vehicle. Sorry, the pole didn't break. In fact, the pole wasn't even hurt. But it was a pretty crazy accident. He sent me the video. I'll share this video with you guys. And big thanks to the customer that sent this out. The only reason I'm going to share this video with you guys is because there was no injuries. If there was any injuries, of course, then we wouldn't be sharing this. But thankfully, the woman that was driving was not hurt. She immediately got out of the vehicle, went to the house that had the footage, and they were able to call 911, and everyone made out okay on that one. But pretty wild shot. So a big thanks to the customer that sent us this footage. Where that is a 3-phase switch, we have to talk to our dispatcher to coordinate with them before closing that in. So we'll give them a quick call. I'm just going to bring up the switch number here on the map. Hey, it's Aaron here. How you doing? Good. I'm just looking to close in a line for a power load here. I guess the boys built the job on the weekend. 8007S378. Yeah, it's not even showing on my map yet. I got the work order number here too, if that helps. It's TRY 505. Yeah, because there was an initial job to hang a transformer bank for temporary power. Yeah, 10-4. Did you say 8007 S308 or 378? Work order. Yes, sir. Yeah, I see that too on the 359 8007 SO78 20 amp at BL4. Okay, so what's the best route? Yeah, and then fuse S378 with a 20 amp fuse in the comments. So is there anything drawn in on your end right now, or? Yeah, that's what they've got on the pole already. Yep, no problem. Yeah, sounds good. All right, thanks. Bye. Okay, so that totally wasn't expected. So this isn't drawn in on the maps yet because it's brand new construction. It's drawn in the engineering side of things. It's just not uploaded into my computer. I don't have a live shot of what's in the field. The pole is labeled as S378. When you look at the work order in the comments, it says please install 20 amp fuses at 8007 S378, which, and we confirm with the pole number, which I couldn't hear the dispatcher because I didn't have him on speakerphone, but it's a long pole number. So the pole number is P78R6L9R3BL4. That number matches up 100%. The device number, we got a 3 on one document and a 0 on the other. This doesn't happen often. It's for that reason that we repeat steps back and forth. When he was saying, okay, go ahead and close 8007 S078, I have marked on my sheet S378. If I wasn't paying attention, I very well could have closed that in. It's not a safety hazard per se. It wouldn't have changed anything other than the number being wrong on the pole. However, down the road, when someone was told to open the switch number and caught it, then it could have caused some mass confusion. Got an electrician coming up to the door here. So just talking to the electrician there, told him to hold up for a few minutes before, once we're going to close this in. As I said, he's going to stop and guard the door, make sure no one goes in that room. But I'm just waiting for a call back from my dispatch. We got to sort out that little mix up on the numbers. This stuff, there's no gray area with it. It's black and white. When you're asked to open a device, the numbers match up 100% or they don't. If they don't, all work stops. You figure out what's going on. So he's making a couple phone calls, and we should have this situation rectified pretty quick. Hello. Okay, so they'll change on the 359 that it's going to be 378, not S078. Yep, 10-4. So that you said an 8007 line at pole P78R6L9R3BL4. I can go ahead and tap on the leads at 8007 S378, and then I can fuse at 20 amp and close 8007 S378. That'll energize pad mount at 8007 P78 R6L9 R3BL4 R1, and you will consider that complete. All right, so we're all good. When these jobs are built, we call it 359. It's basically a blueprint of the job site. On the blueprint, the wrong number was written down versus what was in the description of the work, and on the work order that the dispatcher had, he was looking at the blueprint. Anyways, not a big deal, but it is. Like I said, these things are black and white. It's very important that these are caught. It was caught during the construction before it was even energized, so that's great. Again, that's why we repeat the steps back and forth. And not only do you repeat them, but you don't just mindlessly just ramble them off and just, close this, close. You got to pay attention to the numbers. You got to make sure you heard the pole number. It's like 12 characters long. So you want to make sure every L, R, 3, 0, B, L, all that stuff is 100% correct. So we're all good now. Let's go get that fella closed in. We're going to let the electrician know to clear out that room. So this isn't energized at all yet, but we're going to take a quick peek inside. All right, that door was kind of jammed for some reason. So the boys did all this work yesterday. It's our transformer here, 300 kVA, 12470, phase to phase on the H1 side. And we've got 347-600 coming out on the secondary. There's not a whole lot of cables because of the 347-600 voltage. If this is 12208, there'd be 3 times as many cables. So there's our high voltage terminations there, and then we've just got some caps on the B side to feed through. If another business were to build next door, we could run a second set of cables out of the B side, feed right through this unit and down into the ductwork. Well, that duct's a spare going to that pole, but they could run a new duct in over to another unit. So everything looks good here. Everything's tied in. We'll lock this up and we'll do a voltage check right here once we get everything energized. So for now, we're going to head back inside and get everyone to clear out of the electrical room, and then we'll close that switch right from the ground. So the electrical room is all cleared out, and one of the commercial electricians that's inside is outside of the door, making sure that no one goes in. So like any job, as we're approaching the pole, we're taking a look at everything. As my boom slowly gets closer, I'm looking at that guy from top to bottom. I'm not too concerned about failed equipment or cracked insulators where it's brand new. I'm just kind of double checking the guy's work, make sure everything's tied in properly. Kind of trying to line up that pole with the sun so I can actually see what I'm looking at here. Now, as we tap these on, it's important to not work your way in. You don't want to tap the one closest to and work your way in, because then you're going to be working around live conductors right at your shoulder level. So we're going to start at the far end, tap this guy on first. Watching where the lead is, the tails are measured pretty good here, so the lead's not long enough to get into a ground or the bracket the cutout's on, or another phase or anything like that. Sometimes you'll see guys coil the conductor. It's word on the street is if you have coils in the conductor, it'll create an inductive reactance, which is bad for the power factor of the lines. So I don't know how much it really does if you have 2 or 3 coils in a lead, but it's not recommended. So ideally you do want to measure as accurately as you can without having the lead so long that it's going to flop around in the wind. I was just switching hands right there because it's got something going on with my left shoulder a little bit. One of the fun parts about line work. Moving on to our center. A few things I don't mention in my videos just so I'm not being redundant, but some steps that we take at every job. We test our rubber gloves every time they're being used, check the expiry date, clean the sticks, tailboard, stuff like that that I did in the field but I didn't cover in this video, just again so it's not too redundant, or it's covered more specifically in some of the older videos, and we'll touch on that again in the future for sure. Again, I'm just kind of going slow here because my left shoulder's been bugging me these last couple days, so just try not to agitate it too much here. So I'm going to show you guys something with this last lead where I'm not going to have 3-phase over my head. I can get in a little closer, but I want to show you when you're tightening on tap clamps. You might notice once it's all the way tight, I kind of give it a little flick, and then I'm able to get it usually almost a full turn again after, but we're going to demonstrate that on this guy here. So tap that on, and we're going to give that a spin, and if you watch closely in a second here, it's going to come right tight on us here. So right there, she's getting pretty tight. Now if we were to leave that like that, guarantee you within a year I'd be getting a call here with some American equipment up in the air. What happens is there's a little groove that stirrup sits in, and as you're tightening to the right, it kind of twists that tap clamp to the right, and you can see that it's lifted up on the left hand side a little bit. It's not fully seated in that stirrup or in the tap clamp. So whenever you're putting these on and it's all the way tight, just give it a little flick, kind of roll it around a little bit, it'll slide into place, and you can see we got 3/4 if not a full turn out of that. That being said, if you ever put those on by hand during construction, you don't want to put a screwdriver and over tighten them either. So we're going to close this from the ground. We're definitely allowed to close it from the bucket if we choose to do so, but if I can close these switches from 30 feet away as opposed to 10 or 12 feet away, definitely going to take that option. I've had enough cutouts blow in my face over the years. Much rather close them from the ground. Also, we're going to see, I mentioned a lot of times in my videos when I close cutouts to look away, and a lot of people comment saying, well, geez, we didn't see what happened, you were staring at the ground. In this video, I'm purposely looking directly at the switch just so you can better see what's going on with the stick. It's not a procedure. You don't have to look away according to procedure, but I highly recommend getting comfortable enough with a stick to be able to get the feel of the cutout, once you get the door in position, and when you actually close it shut, look away in case there is an arc flash. Definitely not fun on the eyes if that cutout blows, and that's not to mention the debris that might come flying down at you.
All right, so that went well as expected. We're just going to grab our volt meter now and we'll check voltage right inside the pad mount transformer. 347/600. I expect to see probably something along 354 phase to ground, maybe 614 phase to phase. Building that size, once they put their load on, that'll drag that voltage down quite a bit. So this is all live now. Quite windy out, so it's a good idea to put our little door stoppers there so I don't get smacked in the head by one of these doors. Set that on voltage AC, and we'll just set that meter down on the ground there. So we'll check each one from the hot to the neutral. Alright, let's see what we got. 354.6, 358, and 357.5. Across each hot we've got 619, 614, and 619. So that's all good there. If in the end the customer decides the voltage is a little bit high, we do have an off-circuit tap changer here. That can only be operated with the transformer de-energized. Super easy. We just open the switch up, put a screwdriver in there, loosen off that nut, crank that down. That'll bring the voltage down by, I think it's 2.5%, depends on how this is wired up. We can see there, tap 3, it's 100%, so it's basically at the 60-to-1 ratio, and each tap goes up or down by 2.5% on the windings. So we've got a 5% adjustment on voltage if need be. Also, our entire system is a multi-grounded system. We don't isolate our neutrals. You can see the neutral does have a band tying it to the main bus bar, which is also tied to our concentric neutrals. Our grounds, we've got a 2-aught copper ground down here that's tied into all those bollards around us, as well as a ground grid. So probably won't get anything in this gravel. It's also frozen, but technically speaking, yeah, so we almost got the full voltage, 326 voltage, and that's measuring between our hot and about 3 millimeters into the gravel. So we've got a pretty good ground here, considering we go from 0, well, it's at 6 volts. As soon as we touch that in the gravel, we're getting almost full line voltage at 340 volts now. Over to our neutral, we're getting our 357. And you can see all the bonds on the door, for example, here. We're getting our full 347. Anything that's not energized here is bonded to ground. Alright, sweet, so everything went good there. A couple of things I do want to mention just before we sign off for the day here, guys. And for those of you that watch this channel regularly, I'm sure many of you know now, but these aren't, where's my hat? These aren't DIY videos. And even if you are certified and authorized to do this kind of work, always adhere to the procedures and policies with the company, the jurisdiction, geographical area that you work for. These videos are to help those that are interested in the trade and curious as to what we do.